Before we start with cluster analysis or how to do the clusters, we need to understand the concept of similarity and dissimilarity. Yeah. So these measures is also called as proximity, where it defines on the similarity and dissimilarity. So basically, similarity and dissimilarity are closely related. A similarity measure means it is a measure for two objects. So say we have two objects here, I and J. Okay. Still, please remember, these two objects meaning that each row, okay, in your data set. Okay. So if we have those similarity measures, meaning that we want to see the similarity between these two objects, so it will typically return the value 0, okay, 0 if the object is not alike or unalike, meaning that it is not similar, so it is 0 value. The higher the similarity value, okay, means the object are more alike. So if we say that these two objects A and J is similar, or it is what they call that identical, meaning that it will give value similarity of 1 if this one is identical. Let's say you have 0.7 value of similarity measure, so meaning that this is highly related. 1 will be identical, 0 will be not alike or not related. So usually similarity measure will fall often in a range of 0 to 1. A dissimilarity measure works the opposite way. So meaning that it will return the value of 0. Okay, let me change the color here first. If you want to calculate the dissimilarity measure, okay, it will give you value 0 if, okay, if the object are same. But if you have 1, meaning that the object is not the same or not related. It is different from similarity measure. Yeah? In similarity measure, if 0 meaning that it is not related or unalike, but for dissimilarity measure meaning that 0 is for same related object, and 1 if the object are not related at all. So meaning that the dissimilarity or the not related object is equal to 1. So these two what they call that measures, similarity and dissimilarity measures, is used to create the clusters. If you still remember the definition of clusters, a cluster is a collection of data objects such that the object within a cluster are similar to one another and dissimilar to object in another cluster. This what they call that definition, you must understand it clearly. So to present the data, in order for us to calculate the dissimilarity and the similarity, we need to represent our data structure into two methods. One would be in data matrix and another one is dissimilarity matrix. Okay, so data matrix meaning that, okay, if you have data matrix, it is actually object by attribute structure. See, it is object by attribute structure, meaning that, okay, it is a structure that store the n data object in form of relational table or n by p matrix, whereby our n is our object, our row, and p is our attribute. So let's say you have here 5 attribute. 1, 2, 3, 4, 5. 5 attribute, and you have 3 row. Okay, 3 row. 1, 2, 3. So this one would be your name of your attribute here, yeah. Okay, we will ignore this. So 1, 2, 3 with 4 attribute. 1, A1, A2, A3, A4. So can you imagine how are we going to represent the data matrix here? It will versus the object versus your attribute here. So suppose that we have an object. Okay, this is the real example. Suppose that we have an object. For example, we have person here. Described by P attribute. So you have P attribute here. 4 attribute, for example. Okay, so, and this is called measurement or features, such that age, height, weight, and gender. So this one, A1 would be age, A2 would be height, A3 would be weight, and A4 would be the gender. So the objects are X1. We define it as X1, X2, and so on. Okay, where Xij, okay, Xij is the value for object X, Xi, okay, X for the first attribute of for the first row to the jth attribute. Okay, so 1 here, okay, 1 here will represent row 1. Okay, 1 here will represent column 1. So meaning that column 1 will represent the first attribute here. Same goes to the second object or second row here, X2. So you have X2 here. For example, this is X2. So this one would be X2, 1. This one would be X2, 2. X2, 3. Okay. So in data matrix, okay, it is n data point with p dimension, and it has 2 modes. Okay, 2 modes here. Okay, made up of 2 entities or 2 things. Okay, that are, one would be the row. This is the row. Okay, representing the object, and column for attribute. However, in dissimilarity matrix, meaning that we are going to take a look at the relationship of object by object structure. Previously, we are considering on object by attribute, right? This one, we have another kind of matrix, that is dissimilarity matrix, where we have this matrix to take a look at object by object structure, meaning that object versus object. So in dissimilarity matrix, it is used to store dissimilarity value pairs of object. Okay, dissimilarities, or how it is unrelated between those two objects. And it also represented in n by n table, and this stores a collection of proximities that are available for all pairs of an object. Okay, so we have, for example, 100 objects, so it will store pair of those 100 objects. N by n, so we say that 100 by 100 object. Each object will versus to another object. Okay, so the n data point register the differences of the value of differences between those two objects. So for example, if the value of differences is larger, okay, meaning that they are more differ. If you still remember the concept of dissimilarity previously, okay, we have dissimilarity if the value is 1, so meaning that it is unrelated at all. If the value is wait, yeah, 0, okay, yeah. If the value is 0, meaning that it is same. Okay, so dissimilarity matrix is in triangular matrix because it is n by n table, right? And it is a single mode where it contains one kind of entity, that is the dissimilarity between these two objects. So this is the representation. For example, we have, this is object 1 versus 1. So when it says that 1 versus 1, meaning that it is similar. Okay, so that is why the value is similar or identical. Okay, that is why the value is 0. So this one is talking about the differences between object 2 versus object 1. So this is row 2, right? So this is 2, this is 1, 3, up till n. So we have row here. And we have from here, okay, it also 1, object 1, object 2, object 3, object 4, or object n. Please, please remember this is different from data matrix. Data matrix is object versus row. But now this is object versus object structure, okay? So we have the differences here, differences of object 2 versus object 1, differences of object 3 versus object 1. For here, we have differences of object 3 versus object 2. Why this is 0? Because this is the differences between object 2 versus object 2. So it is a similar object. So that is why it will take value 0. Now, different calculation will be used if we have different attribute, different kind of attribute, okay? So, for example, we have nominal attribute. What is nominal attribute? You still remember? Nominal attribute can take one or two more, can take on 2 or more states, okay? For example, you have red. You have nominal values, red, yellow, blue, different values, and generalization of binary attribute. Or also you can have hair color, black, brown, and so on, okay? So there are two methods of calculating the dissimilarities between two objects I and j. Okay, one would be simple matching, and the second one is use a large number of binary attribute. Usually we are going to teach you on this simple matching method, okay? So in simple matching method, you have two annotation here. M is number of matches. P means the total number of variables. So D is represent the distance. Okay, distant function. If you still remember, this is actually the distant function. I is object I. Okay, J is object J. So you have here I, you have here J. So for example, this is row 1, this is row 2. Okay. So the value of the function would be, okay, the function is P, okay, total number of variable minus M, number of matches, over divided with P here, okay. So if you take a look at here again, M is the number of matches, P is the total number of attribute describing the object. Attribute meaning the column here, okay. Let us take a look at it in detail. So let's say you have one attribute only. Okay, this is only one attribute. We will ignore this object identifier because it is like ID and it doesn't make any differences on our cluster. Okay, so this is our attribute A1. Okay, so we have only one attribute. So if we have one attribute, meaning that what is our P here? P here would be 1. Okay, because P is the total number of attribute describing the object. What about M here? Okay, what about M here? Okay, M is the number of matches. Okay, take a look at here. So you are comparing here, okay, you don't have to compare here because this is the same. D1 versus 1, okay, D2, 2, D3, 3, okay. Let me just write here so that you are clear. D1, 1, D2, 2, this is D3, 3, and this is D4, 4, okay. And you need to remember that if the value is 0, meaning that it is the same, okay, one value of dissimilarity matrix, meaning that it is unrelated or not same. See, if we take a look at here, what is the distance of this one? Okay, D1 versus, meaning that the second object versus the first object, okay. The value of distance function here must be, okay, D2, 1 is equal to, what is our P? P is 1 minus M. M meaning that number of matches. So what does it mean by that? Is code A match with code B? No, right? If this is A, then it is match. But this is B. So this one would be, is there any number of matches? No. So it will be 0. Divided by P, P would be 1 here. Okay. So what is the value? 1 minus 0 over 1 would be 1. So that is why, okay, this is our value here. Okay, let me just erase this one. And this one as well. Okay, I hope you take note on this, yeah? Okay. Let us do the second example on this one. D31, okay? So if D31 meaning that we are comparing object number 3, okay, change the color here so that you can see the differences. Okay, object number 3 versus object number 1. Okay, so this is code A, this is code C. Is there any number of matches? No. Okay, so D3, 1 is equal to P is 1 minus number of matches is 0 over 1. What about, okay, what about D4, 1? Okay, let us take a look at D4, 1 here. D4, 1, I choose red color. See, D4 versus 1. Okay, object 4 versus 1. Okay, see, you have A here and you have A here as well. So what is your M now? M is equal to 1. So D4, 1 is equal to 1 minus 1. Our M now is 1 over 1. So this one would be value 0. So that is why this is 0. Always remember this is a triangular matrix because this value will give same value to its reflection here. Okay, I know you are math students, so I think you can understand this better than others. Say we have two attributes now. Just now we just have one attribute A1 here as a zone code. Okay, zone code. Now we have two attributes. Okay. The second attribute would be the task code. Okay, so if we have two attributes here, okay, what would be our P here? P would be 2. P represent the total number of attribute describing the object. So this one would be 2. What about M is the number of matches? So you have to take a look at, is it having matches in the first attribute and is it having matches in the second attribute, and you have to add them together. So if, for example, if the first attribute has one match, okay, so M1 equal to 1, M2 is equal to 1, okay, for attribute 1 is 1, for attribute 2 is 1, so this one M would be 2, okay. So let us take a look at how are we going to calculate it, okay. So this is for one attribute, yeah. This is different. You need to calculate it together. You cannot write one matrix for each attribute. You need to combine
those matrix with those attributes. So meaning that one matrix for all attributes. So now we have two attribute, right? Zone and task. Okay. So say here we have D21. Okay. So we will take a look at record number 2, object 2 versus object 1. Okay. Could be an A here. Is there any matching? M? So no, it will be 0. What about this one? Okay, could P and could P. Is there any matching? Yes. So our M here would be 1. So what about D 2, 1 here? So our P is how many? 2, right? Here, 2. Minus, what is our M? So we have 0 here, we have 1 here. So our M is 1. Let's say you have 1 here, so this one would be 2. Okay, but then this is only 1, yeah? Okay, 2 minus 1 over 2. So 2 minus 1 is 1 over 2 would be 0 0.5. So that is why you get here 0 0.5. So I hope you can analyze the value for other attribute as well. Okay, other matrix value, Dij for other objects. Okay.